All right, guys, here to do the first part of the practice final. It's 46 questions, so I'll for sure have to break it into parts. I don't know how long your final will be, but I will look up how many questions it's going to be. I think between 30 and 40. All right, so this is an equation it wants us to solve. Tangent of theta minus the square root of 3 equals 0. So when does the tangent of theta equal the square root of 3? So I need one of my perfect triangles. 5 or 6, square root of 3, 5 over 3, 1, and 2. So tangent is opposite over adjacent. So I know that my angle is a pi over 3 angle. So one of them is when it's pi over 3 plus pi k. Remember, tangent is positive in the first, all students take in the second. So it's a pi over 3 angle and a 4 pi over 3 angle. And remember, you add your period, and tangent is always a pi k. But with tangent, what usually happens is I can get 4/3 if I add 3 over 3. So because 1/3 plus 3/3 is 4/3. So I don't have to use this equation when I have tangent. So this is my answer for the first part. I would choose letter A. And then for the second part, what are the solutions? I choose A again, but I would say theta is pi over 3 and 4 pi over 3. So it's technically 2 answers, but 1 equation there. So let me type those in real quick. Pi divided by 3 and pi k. Pi over 3 and 4 pi. I have not completed all parts. Oh, do you see how I did that? I accidentally flipped C instead of A, which would mark it wrong. So double check that you don't make that same mistake when I went to click off of it. Okay, number 2 is an inverse function. So we got sine inverse of -1 over square root of 2. So it says is an angle in the interval. Remember, sines are -π/2 and π/2 with brackets. So I'll go over these real quick while we're on them. So tangent and sine do -π/2 to +π/2, but sine has brackets. Tangent has parentheses. But cosine is only defined at the top. Sorry, I didn't do the negative. Get out and press up. Very good. Remember, so sine and tangent are defined in these two quadrants, -π/2 to π/2. But if we were doing cosine, it would be in the top two right here. Okay, so sine is negative, whereas sine negative in the fourth quadrant. So such that theta, and theta is 1 over square root of 2 when it's a pi over 4 angle. But because it's negative, it's the negative pi over 4 angle. So I know theta is -π over 4. Oh, it didn't do my pi. -π. Why is it not? Okay, where does the terminal side of the angle lie? Well, it's in quadrant 4 or the negative y-axis. So this one. Okay, and then, so what is it? Well, it's -π. Okay, number 3. I'm given the following function to determine the interval of the principal cycle. Oh, it's been a while. So 5 tangent of x minus pi over 3. So remember the ABCD thing. Sorry, I can't see my number. ABCD thing. So your principal cycle is always what's on the inside. So I'm pretty sure tangent is with -π/2 x minus pi over 3. 2 positive pi halves. Okay, so then you're just solving here, gotta add pi over 3. Okay, so this is your fraction rules. You need a common denominator, so it would be 6. So 1/2 is the same thing as 3/6. 1/3 is the same thing as 2/6. So right here, this gives me 5 pi over 6. Well, negative 1/2 is just negative 3/6. Negative 3 plus 2 is negative pi over 6. So the principal cycle is using parentheses negative pi over 6. So 5 pi over 6. Okay, and that's the only part they're asking for now, but remember we could go in and find the leftmost and rightmost point, which means like we have to find the center, and then we take the center and this endpoint and find the middle between those, and then the center and this endpoint, find the center of those. So that was the tangent problem. Number 4. Just gonna go ahead and box some of these answers. Okay, convert the following degree. Oh, this one's easy. I hope you'll have one of these for sure. So 170, for these, you're just dividing by 180 and then putting pi at the top, right? So the zeros cancel. 17 over 18 cannot be simplified. So it's 17 pi over 18 radians. So this is converting from degrees to radians. You multiply by pi over 180. But if it was radians to degrees, remember you do the opposite, 180 over pi. Okay, number 5. Determine, oh, this is one of the ones we just did, the direction angle for the following vector. So v is equal to square root of 3i minus square root of 3j. So remember, you're supposed to do tangent of absolute value of b over a, right? So here I would have negative square root of 3 over square root of 3, which is just 1. So when does tangent equal 1? Well, that's a pi over 4 angle. But then you got to figure out, which is, sorry, same thing as 45 degrees because we're in degrees, but you got to figure out what quadrant it is, right? So here x is positive, but y is negative. When that happens, it's in quadrant 4. So what is the 45-degree angle right there? So you would be doing 360 minus 45, which is 315. That's how you do those. So make sure you don't forget to double check what quadrant it's in. All right, doing good so far. Number 6. Find the angle of least, which is coterminal. So remember, for when we're doing coterminal, you just, if it's negative, you would add 2 pi until you got a positive angle. Here, we're going to subtract 2 pi as much as we can. So I have 49 pi over 12. So 2 pi would be subtracting 24. Right? So, sorry, 49 minus 24 is 25 pi over 12. So I can do it again. Right? And 25 minus 24 is pi over 12. So I can't do it again because that'll be negative. So the smallest, least non-negative measure is pi over 12. But 25 over 12 is also another angle if they ask for them, but this one is the smallest positive one. If that makes sense. All right, number 7. So define an angle on the interval. Remember, cosine is 0 to pi. Okay, can we use cancellation? The answer is no, because 32 over 11 is bigger than pi. It's not in this interval. So we have to do no. So then we got to find out, where does 32 over 11 lie? So right here would be 11. We came back around 22. If we went all the way to this side again, sorry, you can't see, it would be 33 because we're adding 11 each time. So 32 is going to be right before we get to that x-axis. So it's in quadrant 2. And what is the reference? Well, right here would be 33, right? And our angle was 32. So that's 1 pizza slice away. So our reference angle is pi over 11. So basically now your reference angle cancels out, right, what's in the middle of this. So what we're looking at is we're finding cosine inverse of pi over 11 equals what? Oh, no, I'm sorry, I wrote that wrong. So, hang on. Cosine -1 of this 32 pi over 11 is an angle, basically, right? So I know it's supposed to be the pi over 11 angle that's right here, but it can't be 32 because it's too big, right? So, but my reference angle is pi over 11. So what pi over 11 angle is right here? So basically, I'm grabbing the color. So basically, I'm looking for what is this orange angle right here because it starts and stops in the same spot. So if this is 11 originally, 1 less than that would be 12. So your answer is 12 pi over 11. Okay, this was just your reference angle, which showed you how many to subtract. Okay, remember cosines are the hard ones because sometimes you have to subtract if it lands in quadrant 2. If it's not sine or tangent, it's either going to be the positive reference angle or the negative reference angle. Cosine is a tricky one, so I'm glad they put that on there. Number 8. Oops, sorry, I didn't complete the question. 12 pi over 11. Number 8. In the following exercises, 2 sides and an angle determine the information. 1 triangle, no triangle. Okay, so we have to find sine of B. So I have sine of 42.5 over 22.9 is equal to sine of B over 24.4. This is 24.4 times sine of 42.5 divided by 22.9 is equal to sine of B. So I'm going to put that in my calculator. Remember, use parentheses at the top. So 24.4 times sine of 42.5 divided by 22.9. And I got 0.7198, which that's me rounding, is sine of B. So since it's less than 1, it means we have 1 or 2 triangles. Remember, if it equals 1, it's 1 right triangle, and if it's bigger than 1, it's no triangle. So now I'm gonna just put this in sine inverse. So in my calculator, if you can see I have that decimal, I'm just gonna hit sine inverse that answer. It's gonna tell me that B is 46 degrees. This is round to 1 decimal place, but I can't. So I'm just gonna put in 46. I'm gonna put in 46.0 just to be safe because it says 1 decimal place. Okay, so this is for sure B1. Now, how do we know if we have a B2? We got to do 180 minus B1. And I'm writing all this down, so if you want these notes to write down with you, you can. So 180 minus 46 would be 134. I'm going to put 0.0. B2. But you have to check and make sure that this plus A isn't bigger than 180. So 134 plus 42.5, I got 176. So we're good. It's less than 180. Okay, so let me say to check do B2 plus A, and it has to be less than 180. Okay, so I have two triangles. So I'm going to click B right here, and it asks me for B1 46.0, and B2 will be 134.0. Okay, sometimes it asks you to do C as well, but this one doesn't, so we're good to go. Number 9. All right, rewrite the expression as this double angle formula. So you will have your formula sheet again. So I'm gonna write this down and then go look at my formula sheet. So I have 1 minus 2 squared theta basically. So look at my formula sheet. On the computer here. 1 sec. I thought I had it saved. Did I exit out? I'm sorry. Okay. This is my screen share. Share. This is where it's sharing. I don't want to look at my phone. Okay. So where do I get? Hang on, guys. I'm going to pause it for a second. Let's just bring that. One minus 2. So this is cosine double angle. Share back here. Sorry, it was being crazy. I had it saved and then it didn't save. I'm just trying to fix this for. Okay. So this is the formula for cosine double angle. So that's what I'm going to enter here. This is the same thing as cosine times 2. So it would be negative 14 pi over 8. And it doesn't make you simplify right here, but I'm pretty sure if you put 7 over 4, that would be fine as well. So technically, that's what we're looking for. Cosine of negative 7 pi over 4. So I do know that cosine of pi over 4 is 1 over square root of 2. I just got to decide now, is it positive or negative? Well, where does negative 7 pi over 4 land? This is a negative angle. We're going backwards. 4, 8 would be all the way back around, so 7 lands here. It's quadrant 1. Everything is positive. So it's positive 1 over square root of 2. All right, number 10. Determine the general formula of formulas, okay? So sine theta is square root of 3 over 2. This is back to our, I'll draw it up here for the space. Pi over 6 triangle. So when is sine square root of 3 over 2? That's when theta is pi over 3 plus 2 pi k. But sine is positive in the first quadrant and in the second quadrant. So we got the pi over 3, but we need the pi over 3 angle here, which is 2 pi over 3 plus 2 pi k. So for the first part, our answer is B, and this is what we plug in. And then the second part, you choose A, and you plug in your solutions. Well, theta is pi over 3 or 2 pi over 3. I really like to do these. So give me a second while I type it in. You can fast forward this part if you need to. All right, number 11. All right, the point lies on the unit circle, corresponds to a real number. Find the exact values. Okay, so negative would be over here. Okay, so remember, this is square root of 10 because underneath is your radius. And then x goes with cosine, y goes with sine. So your x, what did I just say? X goes with cosine. So cosine is adjacent. -1 and y goes with sine. This one would be negative. Oh, well, I mean, you didn't really need to draw that, okay? So sine is your y value, so it's -3 over square root of 10. Cosine is your x value, which is -1 square root of 10. And then tangent is just the y over x. So -3 divided by -1. Sine of cosine. Yep. And that one was pretty easy. Number 12. Okay, to find the exact value of cosine without using a calculator, use. So where does cosine, or where does -4 lie? So I'm going backwards, but it's going to end up here. So this would be -1, 2, 3, 4. So we're right here on the positive x-axis. Okay, give the coordinates of the ordered pair located right there. Well, that's the points, 1, 0. Okay, so cosine goes with x. So cosine is x over r. So what is the cosine right there? It's 1. Yeah, it says r is equal to 1, so 1 over 1. Just making sure that they didn't change the r for us. All right, so number 13. Sketch the graph of y is cosine. Remember, cosine goes through 1 on the y-axis and sine goes through the origin. So it's not A, B, or C right now. D is our answer. Okay, so is this an odd function? No. Cosine is even. Is the range -1 to 1? Range is a y-axis, yes. Is the y-intercept 1? Yes. Are the zeros of the form n pi where n is an integer? So let's put in 1 and just go look at the graph. Do you have a 0 at pi? So this is 2 pi, this is pi. Do we have a 0 at pi? No. Our zeros are at pi halves. So right here, your answer is no. Just put groups on the graph. And number 14. So use the half angle formula to evaluate the expression. So sine of 3 pi over 8. Give me a second, hopefully it won't mess me up again. The half angle formula for sine is either plus or minus, depending on what it's in. 1 minus cosine alpha over 2. Remember, you will have this one in the sheet. So what is the measure of the half angle? So this is the half angle, the problem. Let me give you a half think about it for a second. So the half angle is 3 pi over 8. The double angle would be when you were multiplying by 2. So we would get 6 pi over 8, which simplifies to 3 pi over. Okay, where does 3 pi over 8 land? That should be in quadrant 1. So because if this is 8, broken into 8, this would be 4. So 3 will be right here in quadrant 1. That makes sense. So quadrant 1, which sign is positive in this quadrant. So we're going to use the positive version of this one. Which basically our answer is just going to be positive. So we're using half angle formula, positive 1 minus cosine of 1. Okay, and then we just gotta figure out what it is. So we're looking for cosine of 3 pi over 4 because we need cosine of the regular angle. So 3 pi over 4 lands in this quadrant right here, and cosine is negative. So, and then cosine of pi over 4 is 1 over square root of 2, but we're using the negative 1. So right here, we have 1 actually becomes plus because minus a negative 1 over square root of 2 over 2. So right here, make sure you pick B because that's the positive 1. And you're going to type that in. 1 plus 1 over square root of 2. Oh, see, I'll put that one next to it. Okay, number 15 is with polar coordinates. So we got 2 and 11 pi over 6. So where does 11 pi over 6 land? So if we're talking about 6 all the way around would be 12. So 11 is going to be right here. Okay, and because my 2 is positive, I want the one that lands in quadrant 4, which I'm guessing is D. So D for that one. Okay, what are the coordinates when R is positive and your angle is negative? So this is going to be 2, comma, 12. Right here would be 12, right? So if I went downwards, just counting this one, it would be negative 1 right there. So negative pi over 6. Okay, scrolling down. B, when R is negative and your theta is positive. So now we have negative 2. And I'm now looking for the one that would be opposite right here. It's the pi over 6 angle right there. If this is 6, 1 less would be 5 pi over 6. So that answer comma 5 pi over 6. And then finally again, R is positive. So we have 2, and when it goes around a full circle. So if we went around twice, this would now be 24, right? Not 12, 24, and we want 1 less than 24. It would be 23. That makes sense. Just making sure 6, 12, 18. All right, so we're gonna have to solve this one. Number 16, I got square root of 2, sine double angle plus 1 equals 0. This is a good one. Okay, so if we got rid of the 1 and the square root of 2, I would get sine double theta is equal to negative 1 over square root of 2, right? So obviously my reference angle is pi over 4, but where's sine negative? Sine is negative here and here. So my pi over 4 angle here is 5 pi over 4. And right here is 7 pi over 4. So now I have to solve the problems. 2 theta is equal to 5 pi over 4 plus my period, 2 pi k. And then 2 theta is equal to 7 pi over 4 plus my period, 2 pi k. Dividing everything in both problems by 2. So I got theta is equal to 5 pi over 8 plus 5k. And theta is equal to 7 pi over 8 plus 5k. Now I need all the answers that are less than 2 pi. So starting with this one, I got 5 pi over 8, right? To add pi, you would be adding 8. So 5 plus 8 is 13. And if I add it to 8 to 13, I would be bigger than 2 pi, because 2 pi here would be 16 pi over 8. Right, so I don't want to go bigger than 16. So I'm going to stop at that 13 pi over 8. Then I got 7 pi over 8, right? And 7 plus 8 is 15 pi over 8. I can't add any more because then I would be bigger than 16. So these are my 4 answers, but I'm going to put them in order. I'm going to do 5 pi, 7 pi, 13, and then 15. I don't know if it matters or not, but just in case. 7 pi over 8, 13 pi over 8, okay, find the area of the triangle. So this we got to use that area formula. Okay, so area is equal to 1/2 b times c. I don't know if it's cosine of it. Let me make sure that formula is right. Yeah, 1/2 BC. Oh, it's sine, not cosine. So don't use that. Sorry. And it basically just depends on the two sides opposite of the angle that they give you. So here I have B and A, and I have angle C. So I'm actually putting B and A right here and C right here. So I have area equals 1/2 of 4 times 1, which is just 4 times, times sine of 1/10. I'm just going to plug that in the calculator. So 1/2 of 4 is 2. So basically 2 times sine of 110. It's not very big, but it makes sense because only one side is 1 point, how many? 2 decimal places, 8 square yards. That's big. And the reason it's so small is because this is only 1 yard right here. And it's half of that, so 1.8 square yards. Okay, that was 17. This is now 18. Okay, use Heron's formula. That one I like. Remember, Heron's formula is the square root of s minus a, s minus c, s minus c. And s is the semi-perimeter. So to find s, you add them all up and divide by 2. So here, s is 11 plus 9 plus 15, 35. Yep, divided by 2, 17.5. I got 17.5 minus 11, 6.5. 17.5 minus 15, 2.5. And 17.5 minus 9 is 8.5. So 8.5 times 2.5 times 6.5 times 17.5 is this long decimal I'm not going to plug in, and then I'm just going to take the square root of that answer. So I got 49.1649. See how many decimals. Round to 2 decimal places. That is needed. So 49.1. Right, number 19. Okay, tangent. It's from pi halves to pi halves, so it goes through the origin, but it goes up. So it should be this one. Goes through the origin and has to go up. Because cotangent goes down. Stops. So this one is cotangent. So this one is tangent. Okay, is it an even function? No. Is the y-intercept equal to 1? No. Is the range negative infinity to infinity? Yes. Because it goes down forever, up forever. Is the period, what is the period of the function? The period is negative pi halves to pi half. No, that's the principal cycle. Sorry, the period of tangent is pi. And y'all know that already. Okay, that one's good. Tangent graph. I think they'll probably ask you for all 3 graphs, so I would make sure you know what they look like. Okay, number 20. Okay, determine the polar coordinates for this one. Okay, so this is the rectangle. Yes, okay. So remember, r is equal to the square root of x squared plus y squared. So here, x is negative 23 squared would be 23 plus square root of negative 23 squared is another 23. So 23 plus 23 is 46. So r is the square root of 46. I don't think a perfect square goes in. So r is the square root of 46. That one goes first. Yes, and then tangent of the reference angle is y over x. So here, I'm sorry, let's see, would be negative square root of 23. Over square root of 23. Negatives cancel out, and that divided by itself is 1. So I know that my reference angle is pi over 4. So double check, where did the rectangle coordinate land? Well, x was negative, y was negative, so it landed in quadrant 3. What is the pi over 4 angle in quadrant 3? 5 pi over 4. So here, all right, 21, another vector problem. Okay, so we gotta find A and J. And if you remember, I'll write these formulas out for you. Just a second, make sure I have them right. Yes. A is the magnitude times cosine, and B is the magnitude times sine. Okay, so here, sorry, I moved it up. Right. I'm gonna have 23 times the cosine of 210, and this one is 23 times sine of 210. So we got to think about 210 in radians. So 210 divided by 180, basically, is 7 pi over 6. So 210 is the same thing as 7 pi over 6. Where does that land? 7 pi over 6 is in quadrant 3. So sine is going to be negative. So it'll be, this will be 23 times a negative. But cosine is positive. Does that make sense? And then we need my pi over 6 answers. So sine of pi over 6 is 1/2, negative 1/2, and cosine of pi over 6 is 1 over square root of 3. So here in the first part, I'm going to put in 23 over square root of 3 goes with the I. Plus, right here, we're going to put in negative 23 over 2. So, 23 over square root of 3. And j negative 23 over 2. I just feel like something's wrong. We'll see. All right, 22. I'm probably going to let this be the last one for this part because it's about, well, I'll go to 23 if I can fit them both on this piece of paper because that'll be helpful. All right, solve the triangle if A is 8, B is 9, and C is 60. Okay, so we have to use law of cosines here. So law of cosines, we're going to have to find little c first. So c squared is equal to a squared plus b squared minus 2ab cosine of c. So that leaves me with 8 squared plus 9 squared minus 2 times 8 times 9 times cosine of 60 degrees. So let's see, 64 plus 81 is 145 minus 2 times 8 times 9 is 144 cosine 60. So in my calculator, so 145 minus 144 times cosine of 60. And then take the square root of that. Okay, I'll make sure I did that right because it said this was 73. So I'm just double checking. 144 times cosine of 60 is 72 and 145. And that. 73, yep. Square root of 73. It tells me that little c is 8.54. Round to 1 decimal place. I messed that up last time. 8.5 is little c. Okay, so now we could use law of sines to find the rest, right? So I could have sine of 60 over 8.5 is equal to sine of 8 over, sine of a over 8. So sine of a equals 8 times sine of 60 divided by 8.5. So 8 times sine of 60 divided by 8.5, take sine inverse. And I got that A is equal to 54.1 decimal place, 0.6 degrees. Okay, and then for B, we can just subtract 180 minus 54.6 minus 60 is 65.4. One more problem. Approximate the solution in the calculator. Okay. So these can be a little tricky. Okay, so it's saying find the negative of that. So if I put in sine inverse, oh, it wants it in radians. Hang on, make sure your calculator is in radians. Double check that. So sine inverse of negative 0.25 is negative 0.25. Okay, so it's giving me this answer right here. Okay, but this is a negative angle. So it's giving me negative 0.2527 because it's 4 decimal places. Okay, so, but it wants only positive answers. So because, and I know it wants positive answers because it says 0 to 2 pi right here. Okay, so I need to find the positive answers when sine is negative. Well, sine is negative right here, but instead of this one, I need this one. That makes sense. And then sine is also negative right here. So I need those two. So first, I'm going to find my reference angle, which my reference angle always goes right here. But it would be the opposite of this, right? So my reference angle is 0.2527 with the positive version, right? So this one right here would be pi plus the reference, because this is the same as this. That's the reference angle. So I'm going to do pi plus the reference angle for my first answer. Let's see, pi plus that answer gives me 3.394. Yep. Okay, and then here, this is 2 pi, right? And this is the same thing as the reference angle. So you're going to do 2 pi minus the reference angle for your second answer. So 2 pi minus 0.2527 is 6.0305. So I hope that kind of made sense and that like my little drawing made sense. I'm going to type it in. 3.3943, comma, 6.0305. Now, if it gives you a positive answer right here, you don't have to worry about switching the reference because it's going to give you whatever is in quadrant 1. But because this one was negative, it gave me the one down here in quadrant 4. So I hope that makes sense. That's part 1 of your final. I will do the other video tomorrow.